Good morning, everyone. My name is Alan Gayle. My register number is URK23AI1051. In this video, I am going to explain experiment number 5, which has three subdivision: time series prediction, car sales prediction, and stock prediction using RNN. At first, we start by importing libraries such as NumPy, TensorFlow, Matplotlib, and MinMax Scaler. Then we generate a synthetic sine time series by combining two sine waves with different frequencies, adding some noise to make it more realistic. This simulates the data changes over time. Next, we reshape and normalize the model using min-max scalar so that all values are between zeros and ones, which helps RNN to learn efficiently. A helper function is used to split the data in input and output pairs, where model learns from sequence of 20 previous time steps to predict the next steps. Uh, Then we divide a data set by training and testing sets of 80% for training and 20% for testing, and then reshaping the data with a 3D form suitable for RNN. Then we build a sequential RNN model for 50 neurons in a simple RNN layer and one for dense layer, that is output. It compiled with Adam optimizer and mean squared error loss function, which is ideal in regression. The model is trained for 20 epochs, learning to recognize pattern on trends in time series. After training, it is evaluated for testing data and metrics like loss and mean absolute error for calculating the check accuracy percentages. The model's prediction are compared with the actual values using Matplotlib. The plot displays actual versus predicted curves, showing how closely the RNN can follow time series trend. In short, the code demonstrates how an RNN can learn temporary relationships in time-dependent data, concept widely used in fields like weather forecasting, energy demand prediction, and sensor data analysis, etc. In the second program, which focuses on predicting stock price using RNN, we begin with importing necessary library including Y Finance, which is used to download real-world stock data. Here we select Apple stock data from January 2020 to January 2023. We extract close price as our target time series. Then we normalize the data using min-max scalar, and we use same create sequence function to prepare 60 previous day of data to predict next day's price. Reprocessing. We split the data into training and testing sets to reshape them into a correct format for RNN input. The model architecture includes two simple RNN layers with 50 neurons each. First returns sequences and second output results the final, followed by dense output layer. This model is compiled using Adam optimizer and mean squared error loss. Then we 50 epochs. Train for 50 epochs. During training session, the RNN learns temporal dependency in the stock price. After training, it evaluates the model performance and computes the mean absolute error to measure prediction and accuracy. Then the code visualizes actual versus predicted stock prices using Matplotlib, giving a clear picture of how well the RNN follows market trends. Coming to the third code, The third program predicts car sales trend using recurrent neural network. We start by creating synthetic car sales data using NumPy. It represents gradually increasing sales with adding seasonality and random noise to making it realistic. The data is reshaped and normalized using min-max scalar. Using create sequence function, we prepare input-output pair where each input sequence of a time steps predicts the next sales value. After splitting into the dataset for training and testing parts, we reshape it for RNN input. After that, the model is built using simple RNN layer with 50 neurons followed by dense output layer. We compile it using Adam optimizer and mean squared error to find the loss and minimize prediction error into working. Coming to working and output, the model is trained for 50 epochs, learning from sales trend. After training, we evaluate its performance with loss function and mean absolute error matrix. Finally, we visualize actual versus predicted car sales using Matplotlib. The resulting graph shows how accurately the model predict future sales based on past data. In summary of this code, it demonstrates how RNN are used in business, such as predicting sales, production demands, and revenue trends, helping companies to make data driven decisions. Thank you.